Okay, so here's the file, and because you can't undercut, what we're doing is just reversing it and using the opposite edge of that surface to create the same curve cut toolpath. But remember, the toolpath is offset by the selected tool's diameter. So it's actually going to be offsetting it in the wrong direction, right, into the material, as opposed to, normally if you were toolpathing this side, which is what you're doing, this side over here, then all these green lines would be that much further on this side. So that's your translation of this surface out away from where the cut is actually happening. Um, Also, I pointed out using a tool center instead of tool tip will have to be calculated, because if you use tool tip, then this comes down and it touches and then it gradually goes out like this, and that won't work for what you're doing. I think what you need is a perfect, when you use tool center, then it just keeps that even distance away. It's just from the center of the tool. So you have to consider, you have to think about the tooling and where the calculation of that center point is, along with you know how wide the tool is to move that surface up. And then the other thing I think I don't know if I was clear. I'm sure you may understand this, but about the ball cutter, um, you can't program a ball, or whatever you would call that, a sphere cutter in Bobcat, so it's just a straight shaft. So essentially what you're doing is you're just you're just it's just going to be calculating as if this was a straight shaft down here. So you have to just know how much extra distance from here out this way is with that tool, and then do the judging and the calculating that. So it's going to come down and follow the paths you created, and how far. You said that your ball actually does the undercut, so you can't program the size of the sphere down there. Uh, you don't program this size in. You have to program in the size of the shank, and then just know that the sphere is cutting. So that whatever those are going to have to be taken into account where you put this, to be able to have the tool path that's created here actually follow at this given point right here. If, I'm not a machinist. You may already understand that, and there's probably other guys. There's definitely other guys here that could explain that better as far as crunching the numbers. The file I'm putting up doesn't. This file right here is the one you'll have. It's just all generic numbers. I didn't do anything like that. I didn't sit down and think about that. So there's not you're not going to be able to look at this and crunch the numbers in the feature. You can just look at this and go, I selected that geometry and use that boundary, and that geometry and use the boundary. And there's a couple of edits in the features you can see to make it go right here. Like this is just a normal Z-level finish right here, because all I did was select just that piece right there. But I'm also programming it, and I'll have to offset this piece down here this way some, because that shank, this toolpath isn't going to work if this was actually a ball, then you're actually cutting way back over here with the edge of the ball, because it's only programming that straight part of the shank. So this has to be translated over this way enough so that that the actual surface of the ball that's cutting is cutting where it's supposed to. Anyway, hope that makes sense. Maybe someone else can jump in and explain it in machinist terms. Thanks, bye.